So let's talk about our next adventure when creating an EC2 instance. After we've gone through all these options, the next thing you see is this button to add storage. Now this is where you add extra disk drives to your server, or just keep with the one root drive that you are required to have. And you can decide what type of storage you get and how much. Now the default and the lowest is 8 gigabytes, and you can get many, many more gigabytes than that. And the size you get and other factors drive certain aspects of certain volumes. So we have all these volume types. GP2 is the default, GP3 is newer, and then we have the older IO1 and newer IO2 for provisioned IOPS, which is basically paying extra for the ability to get more IOPS, which is input-output operations per second. And of course, there's magnetic as well, which is not very well used, except for very specific use cases. Okay, so what is going on with GP2, 3, IO1, and IO2? Rules of thumb in AWS are basically to use the newer stuff because they're often faster and cheaper, which is true for IO2 and GP3 over GP2 and IO1. Now, IO1 and IO2 are very expensive relative to GP2 and GP3, and I typically stay away from them because if you're trying to get over bottlenecks in disk drive usage, in other words, they aren't acting as fast as you want them to, it is often due to other reasons that are not IOPS. And in IO1 and IO2, you're basically provisioning extra IOPS. So you're getting speedier disk drives, but very often you're more constrained by your bandwidth and throughput. To get equivalent speeds in GP2 and GP3 through then versus the IO1 and IO2 types, it's often cheaper to get better GP2 or GP3 disk types than IO1 and IO2. But you have to do the math on that and try to understand what your bottlenecks are. Okay, so by convention, stick with GP3 by default because GP3 has certain aspects to it that are nicer. It's cheaper than GP2 and it gives you 3000 IOPS and 125 megabytes per second of throughput for free as a baseline. And you can increase these and pay extra, but the first 3000 IOPS and the first 125 megabytes per second of throughput are free, while GP2 starts you at 100 IOPS as a baseline and lets you burst up to 3000, but that is a credit system, just like the T3 instances have a CPU credit system. So you run out of credits, then you're stuck down to 100 IOPS for any size under 1000 gigabytes. Okay, let's actually see the documentation on that a little bit to understand that a bit more. So we have the volume types page here, GP2, GP3, and IO2. And IO1, of course, but I'll talk about IO2 just a little bit. So GP2 has a price of 10 cents per gigabyte per month. And GP3 has a price of 8 cents per gigabyte per month, so cheaper immediately. GP2 gives you 3 IOPS per gigabyte, so the larger your disk, the more baseline IOPS you get. So you have 100 minimum of IOPS, and once you start adding more gigabytes, you get more of a baseline of IOPS. So we saw we had 8 gigabytes, and if we multiply that by 3, we'll do 24 IOPS, right? That's not very much, so it just goes to the minimum of 100. And you get a maximum of 16,000. And provides up to 200 megabytes per second of throughput per volume. So GP2 volumes smaller than a terabyte can burst up to 3000 IOPS, but it's a credit system. So the max IOPS is 16,000 if you get a big enough disk drive. The max throughput is 250 megabytes per second. The max IOPS per instance, pretty high. Max throughput, 75,000 megabytes per second, again, high. Now the GP3 works a little differently. GP3 has a minimum of 3000 IOPS and 125 megabytes per second for free, which is what you can burst up to in GP2. So GP3 starts at a higher baseline than GP2, right? So it's better and cheaper, essentially. So it's newer, it's better, it's cheaper. It probably should be your default type. Now, it doesn't give you more IOPS or throughput as you get a larger amount of disk drive of storage. So you pay half a cent for every provisioned IOPS per month over 3000. And 0.04, so 4 cents over every megabyte extra you add over 125. Okay, so GP2 here, right? You can see if I go up to 100 gigabytes, then I have 300 baseline because it multiplies it by 3 per gigabyte, right? That's your baseline IOPS. If I go to 500, I get 1500 IOPS baseline. If I go to 1000 gigabytes, then there's no bursting anymore. There's no credit system for IOPS. Instead, you just get the 3000 IOPS. For, roughly a terabyte of storage. And if I go up from there, say 3000, so 3 terabytes, then I have 9000 IOPS of my baseline. Throughput is NA because you're capped at that max throughput, which is 250 megabytes a second, I think I saw. All right, so back to 8 for this. If we go to GP3, we'll see this doesn't change no matter how much storage you add. So if I do something like 4000 gigabytes, The IOPS doesn't change here because these are separate. You can add as many IOPS and throughput as you need up to the maximum. And for GP3, we can see what those max are. So the maximum throughput is 7,500 megabytes per second. Max IOPS is 260,000, quite high. Max throughput per volume is 1,000. Okay, so this is per instance, but per volume is 1,000 megabytes per second. And if we check out just IO2 real quick, we'll see it has a different pricing scheme altogether. So it's basically made for higher speed. So a baseline of 500 IOPS per gigabyte, which is a much higher baseline. And we can see it's more expensive, right? So 12.5 per gigabyte per month in storage. And then, of course, you pay for extra IOPS provisions as well at a rate that is higher than the GP3. So 065 versus over here, 005 for provisioned IOPS over 3,000 for GP3. Okay, so it's a bunch of math. You have to do the math to see what makes sense for you. But the rule of thumb is to use GP3 because it's faster and better for GP2 for your baseline amount of IOPS and throughput. Okay, so the next thing, if you actually do decide to pay for extra IOPS and throughput, you should know that your servers will limit you as well. It's different server types. So we go down and find our T3 instance types here. And I should notice this is under EBS optimized by default. We'll read a bunch of stuff about EBS optimization, but most servers have EBS optimization on by default. So it's not really a thing you really have to think about for the most part. All right, so T3.large and other T3s here have a maximum bandwidth, right? So a maximum bandwidth of 2780 megabytes per second, a maximum throughput of 347, and a maximum IOPS of 15,000. So if you purchase and pay for EBS drives that have higher throughput, higher IOPS, and use more bandwidth than this stuff, you're still going to get capped because the server type has these maximums. So if I have a T3 large and I pay for over 15,700 IOPS, I'm going to get capped at 15,700 IOPS. I can't get beyond that. So you have to be careful about that, especially in the smaller server sizes, if you're going to use provisioned EBS drives with extra IOPS and extra throughput purchased. All right, so performance, I'm going to just go to this FAQ about EBS. Scroll down to the info about GP3 and GP2. So what level of consistency can I expect? High consistency. What level of performance latency? Do general purpose GP3's volume have a burst system? They do not. How does burst work in GP2 volumes? So volumes that are under 1,000 gigabytes, which is what we saw, receive a burst bounce for up to 3,000 IOPS. Once you get to 1,000 gigabytes, then you can do 1,000 times 3 because you get 3 IOPS per gigabyte, and you're at the 3,000 IOPS. So after that, it doesn't make sense to use a credit system to burst up to 3,000 IOPS anymore because you're already at 3,000 IOPS as your baseline. So 500 gigabyte volume gives you 1,500 IOPS baseline, and you can burst up to 3,000. Okay, so here's another little thing on burst versus baseline performance. This person has created different drives of different sizes. The 100, 200, and 500 gigabyte GP2 EBS drives all burst up to 3,000 IOPS. And then once those credits are used, because they've burst for this amount of time and no longer have any IOPS credits left, all drop to performance to their baseline. While when you get over a terabyte, over 1,000 gigabytes, you have a consistent baseline of IOPS with no credit system, and so your performance stays steady through your workloads. Okay, next point is a handy graph here, which is useful for making decisions for things like your database if you use RDS. Just a quick graph of basically all of what we've been saying. Depending on the volume size, you get certain aspects, right? So a volume size of 1 gigabyte still has a baseline of 100 IOPS, 250, 750 baseline. Once you get to 334, it's the max size for max throughput. So at this point, you're not getting any more extra throughput when you add extra disk size. And again, this is for GP2. And once you get to 5334 gigabytes, so 5 terabytes, more than 5 terabytes, then you're at 16,000 IOPS, which is the max IOPS you're going to get. There's no longer any bursting or anything like that anymore. There's no burst duration. And this is kind of the magic level that you often see people add to your GP2 disk when you're using with your RDS, your databases, because you get the baseline, the highest baseline of IOPS. And it's cheaper than provisioning extra IOPS using an IO2 disk drive for your database instances, and really for any EBS drives in general. But in RDS, that's typically where you see it because people want to get their performance to be as high as possible for their databases. And I'm talking about RDS because RDS is the relational database service that AWS gives. You can do this for your regular EC2 servers as well. Now, again, this is a lot about GP2 because GP2 is still very popular. GP3 isn't yet available for RDS instances as the time of this recording. And GP3 in general, I think, is what you should be using. So that's a lot of description, all of which is to say just use GP3 by default. Keep your baseline IOPS here and increase those if you need, but often you'll find other bottlenecks before you need to increase your EBS speed. And of course, always keep in mind that those IOPS, operations per second, but your throughput and how many or the size of the packets that you're sending through to your EBS drives to save data to your disk are all important factors to consider.